Okay, good morning, Veritas scientists. It is April 2nd, 2020. I hope you watched my video yesterday. It was called River Erosion and Deposition. So check that out because I was outside in the woods looking at a river that had a big curve in it, and that's going to help you with today's assignment. So go watch that one first and then come back and you can watch this video afterwards. All right, so let's do a quick review. What we learned 2 days ago, or let's see, Wednesday, yeah, yesterday. What we learned yesterday on April 1st was about weathering, erosion, and sediment. So we learned a new vocabulary term called sediment. Those are the tiny pieces of rock that break off of a larger rock through weathering and land in a body of water through erosion. So we've been saying this saying all week. Weathering breaks it and erosion takes it. So weathering, if we have a mountain here, here's Mount Tom. There's a big rock up at the top of Mount Tom. The weather hits it, wind crashes against it, rain, snow, hail, sleet, all crash up against this rock. And it's called weathering when it is breaking off into little pieces. Okay, those little pieces are called sediment. Okay, and those little tiny pieces of sediment, when they are moving somewhere else, that is called erosion. So when it rains or snows, this runoff, the water runs down to the lowest point of elevation, and it's going to eventually land in a pond or an ocean or a lake. Okay? So the erosion is the movement of that sediment that was broken off by weathering. Okay? And then the sediment settles to the bottom of a body of water. So if it's sitting in a lake, it is going to be heavier than the water, and it's going to sink down to the bottom. All right, and that leads us into, let's see, the questions that we had from yesterday. Number one says, what happens to the sediment that sits at the bottom of a body of water over a very long period of time? We'll get to that in a minute, but I got to teach you some new vocabulary. And number two says, what happens to the sediment that lands in a river? Because if it lands in a body of water where it's going to settle to the bottom, that sediment is going to have something happen to it. But if it's moving in a river, something different is going to happen to that sediment. All right? So here we go. That was some review of yesterday's. Now we're back to a new lesson for today. So today's Thursday, April 2nd, 2020. Science, soil, deposition, and erosion. Okay? So deposition is the same word. Deposit would be the verb. Deposition is the act of depositing. Okay, so we're going to learn this word deposit, which means to put or set down. So if you deposit something, if I were to deposit this pen onto my paper, I'm going to put it down. Okay, or to drop something off or place it in a certain location. Okay, so most of us use the word deposit when we're talking about money at a bank, right? You go to the bank and you deposit money. You put the money into the bank. You basically put it in that location, okay? So here's an example. The sediment that lands in a river is either deposited somewhere in the river, watch the video from yesterday and you'll see what that means, or that sediment is taken further downstream through erosion, okay? So watching that video, you'll see that sometimes it lands in a spot, it gets deposited in a certain spot in the river where the water is not flowing as fast. Or it is taken further downstream through erosion. Okay, so that is the word deposit. It is being dropped off in a spot. Okay, so yesterday we saw the curve of a river going this way. The water is going this way down the stream. This water on the outside of the curve is moving a lot faster than it is here on the inside of the curve. So those little pieces of soil that are floating down in the river because the river is moving, these little pieces of sediment or little pieces of soil are going to be deposited here where it is slower. So this water is not moving very fast. If you watch the video, you'll see what I'm talking about. It gets dropped off here. It gets deposited here. So this will build up with sand over time. It will build up with soil over time. That sediment will all get deposited on the inside here because the water's not moving as fast. And the water on the outside is moving fast, which you can see in that video from yesterday. So erosion is happening on this side. because more of that soil is being broken off of here and carried down the river, but it is actually being deposited on this side, which we talked about in the video, turns into these giant curves because you're going to end up having more soil deposited here, which will become part of the land, and you're having it being broken off of this side, which is going to create this giant curve over time. All right, so deposit would be to drop off the sand right there in that spot. Okay, so here's number 2. This word is cementation. It's got the word cement in it. It is the act of cementing something. Okay, so cementation is when something hardens over time to become joined together and hardened as one. Okay, so an example, sedimentary rocks are formed over time through cementation. So we're going to continue talking about rivers for the next few days. We're going to continue talking about how rivers are formed and how they change shape over thousands and thousands of years. But this is what we're going to get to next after that. But I wanted to bring it up now. That way when we get to rocks and how rocks are formed, we will have a little bit of background knowledge to help us with that. Okay? But we needed this word to help us with yesterday's questions. So let's go back to those. Number 1 says, what happens to the sediment that sits at the bottom of a body of water over a very long period of time? And quite simply, what happens is cementation. And this we're going to just touch upon today, and we'll get more into it as this moves up, as we move on. So here is a body of water. It could be a lake or a pond or an ocean. It is a body of water. Okay? When that sediment falls and erosion brings it to this pond, it is all going to settle down at the bottom because the sediment is heavier than the water. So after a little bit of time, all the sediment is going to sink to the bottom of that body of water. So now you end up with all this sediment settled down at the bottom of that body of water. Now all the water on top of it is pretty heavy. It's very heavy. So if you're at the bottom of a body of water, you have a lot of pressure on you pushing down. There is a lot of weight above you pushing down on you if you are way down at the bottom of the water. So what happens over thousands and thousands and thousands of years is that the pressure pushing down on all this sediment makes cementation happen. It cements and it hardens and becomes rock. But that takes a really, really long time. First, it's going to become part of the soil down at the bottom, but over a very, very long period of time, it is actually going to harden due to the pressure and the weight of the water pressing down on it, and the atmosphere above it is all pressing down, including gravity is pushing down everything onto this, and over very, very long period of time, it is going to cement and it's going to turn into a sedimentary rock. So the sediment turns into sedimentary rock. That's where the word sedimentary came from, is because it was formed by the sediment at the bottom of a body of water. Okay, so that's what happens over a very long period of time with that sediment that sits down at the bottom of a body of water. Okay, number 2 says, what happens to the sediment that lands in a river? And the short answer to this is some of it gets deposited. It gets dropped off, just like we talked about in the curve of that river. It gets dropped off here where the water is moving a little slower. So watch that video from yesterday because that'll make a lot of this make sense. It gets deposited in some spots and some gets carried further down the river. Okay, so some of those pieces of sediment, if the water is moving fast on this side, that sediment is going to be carried by the water and it's going to be pushed. It's going to bounce, some of it's going to float, some of it's going to skip, but it's going to make its way further down river. Some of it will be deposited, and some of it will be in the water and will continue going down the river. Okay? Now, here's today's assignment. We're almost done. You guys are doing a great job. It says, watch the YouTube video that I made yesterday titled River Erosion and Deposition. Please watch that because that'll make this make a lot more sense. So here's the question I have for you. It's number 1. It says, the video shows that rivers get more curved. That word is windier, not windier, or more windy. There's nothing to do with the wind. I'm just talking about becoming more curved, right? More windy, right? Rivers look like this over time, right? They become more windy, okay? Due to erosion and deposition, okay? So that's what the video shows, that river gets more curved, it gets more windy over time due to erosion and deposition. I want you to explain in writing how that happens. Be sure to use the words erosion and deposition in your response. Also, draw a model to help explain your writing. So I want you to talk about what that video is teaching you about. So you're really the answer is in that video. You just have to watch that video. You might have to watch it a couple of times. Okay? Why do rivers get more curved over time due to erosion and deposition? All right, and try to draw a model of a river to help show that. Now, this is going to blow your mind tomorrow, but here's a preview for tomorrow's lesson. It says the oldest rivers are actually straight. What? Why? Tune in tomorrow to find out. So we are basically learning now that rivers over long periods of time become more windy. So how could this fact, it is a fact, how could this possibly be true? Based on everything we just talked about, how rivers become more windy because soil is deposited here and it is eroded from the outside, making it a bigger curve. So if that is true, which it is, that rivers get more curvy over time, how could this be true, that the oldest rivers are actually straight? Think carefully about that. To be honest with you, I learned this in college. Pretty cool stuff. We're going to learn some new vocabulary tomorrow, but this is something I would really like you to think carefully about today. All right? So that's it. Hope everybody has a great night. Tune in tomorrow to find out why the oldest rivers are actually straight. Take care. See ya.